All right, we're going to talk about section 8.7 today, which is talking about systems of equations. We're going to talk about linear systems with two variables, and we're going to talk about two methods, the elimination method and the substitution method. So when you're graphing two systems of equations, or two equations, they're considered to be a system when the two lines will intersect, or when you can make a decision about some sort of solution that these two equations have in common. So if you look at these two equations that we have here as an example, if I were to graph these two equations on a regular graph, these two equations would intersect at some point. So if I graph the first one, and I'm just going to do a really rough graph to give you an idea, my y-intercept is 4, and my slope is 3/1. So this is a very, very rough sketch, but there's my graph basically. And then my other graph would be at the y-intercept of 2 and a slope of -2. And so here's my other graph. And those two graphs are intersecting at this point right here. And that's what we call the solution to the graph. And that's what we're trying to find with these problems, is where do the two equations cross? What is their solution? So the example that we just talked about briefly is something like this, where there's going to be one solution. This is called a consistent equation, and it's independent, and there is one solution. The two lines will cross, and they cross at one point. Okay, but there's two other possibilities for what can happen. The other possibility is, what if the two lines are parallel? Okay, so these two lines are parallel. And by definition, parallel means they will never cross. So the problem is that since they never cross, there is no point that they have in common. So there is no solution to the problem. These two problems are considered to be inconsistent, and they are independent. All right, and the last possibility is when we have a problem where both of the lines are actually on top of each other. So let's say I had the problem 2x plus 3y equals 4. And my second equation is 4x plus 6y equals 8. Well, you'll notice that really these are the exact same equation. All I did was take the first one and multiply it by 2. So what happens is it's the exact same line, but it's written in two different formats. And so technically what I have here is not just a graph of one line, but two lines that are on top of each other. So if I were to ask you, how many times do those two lines touch? They touch infinitely many times. So there is an infinite number of solutions. This type of problem is considered to be consistent and dependent. Okay, so quick review real quick. There are three possibilities. The two lines could intersect at one point, and there is one solution. The two lines are parallel to each other. They have nothing in common. They never intersect, therefore there is no solution. And the third possibility is that the two lines are overlapping. They basically are the same line on top of each other. Therefore there's an infinite number of solutions, and well, that's it. There's an infinite number of solutions. So what we're going to talk about now is how to determine what the solution is using one of a number of methods. And the one we're going to talk about first is called the elimination method. And the two that we're going to go over are probably the most common two methods that you're going to use. So with the elimination method, the idea is to try and eliminate one part of the equation, either the x's or the y's, and then you can simplify the rest of the problem to work it down. So there are a couple rules. The equations have to start off in standard form, so ax plus by equals c. That's the first rule. You got to make sure they're both in standard form. And then what you're going to do is you're going to multiply one or both of the equations, it depends, by some number so that either the x or the y is 0. And then you're going to add the equations together so that that variable is eliminated. And then you're going to solve for the equation and then substitute the values in. So let's look at an example of what I'm talking about. So here we have two equations. We want to solve by elimination. Now there's more than one way to work these problems out, but you always want to try and figure out the shortest way. In this case, you will notice that the y's, one's positive and one's negative. You'll also notice that the coefficient on this one is -2. The coefficient on the second equation is technically a 1. So if I were to multiply the entire second equation by 2, then this part here would become 2y. And then my y's would be opposite of each other. And that's your goal. So that's what I'm going to do. I'm going to multiply the second equation by 2. So both of the equations are in standard form. We already talked about that. And we're going to multiply the second equation by 2. So when I do that, I get 4x plus 2y equals 10. And that's where we got this equation down here. Now notice the first equation did not change. It is still 3x minus 2y equals 4. So the next step says to add the two equations together. So 3x plus 4x is 7x. Negative 2y plus 2y is 0. And 4 plus 10 is 14. So now I have a problem that I can just simply solve for x. Divide both sides by 7, and I get x equals 2. So that's what I've done over here. I set up 7x equals 14. I solved and got x equals 2. Now what you're going to do is you're going to go back to the original problems. And it does not matter which problem you go back to. You can go back to the first one or the second one, whichever one you feel most comfortable with. And we're going to take that 2 that we just got for x, and we're going to substitute it back in. So I'm going to pick the second one. So 2 times 2 plus y equals 5. So 4 plus y equals 5. So y equals 1. Now if I substituted it into the first one, 3 times 2 minus 2y equals 4. 6 minus 2y equals 4. Minus 2y equals negative 2, because I subtracted 6 from both sides. So y equals 1. I got the same answer. So it really does not matter which equation you choose to substitute it back into. But when I substitute it back in, I got y equals 1. So now my solution is the point x equals 2, y equals 1. So it's the ordered pair 2, 1. So again, what that's saying is that I have an equation, I have two equations, and the two lines, I'm not sure exactly what they look like, but one of them might look like this, the other one might look like this, but those two lines are crossing right here at the point 2, 1, and that's our solution to the problem. If we want to check our solution, what we can do, again, let's go back to our original problem. We can put 2 in for x and 1 in for y and see if the problem works. 3 times 2 minus 2 times 1. 3 times 2 is 6, minus 2 is 4. So it works for this problem. Do the same thing for the other one, because just because it works for the first one, it's got to work for both of them. So 2 times 2 is 4, plus 1 is 5. So you were able to check and make sure that that is in fact the solution to the problem. All right, so another method, this is just another option, is called the substitution method. And the substitution method is, the goal is to get one of the variables with a coefficient of 1 or -1. Um, this tends to be the most popular method in a lot of classes. Now, what I tend to do is look at the problems that are given to me and make a decision whether I'm going to do elimination or substitution. Um, Graphing is usually the last option, even though that gives you a good visual, but usually either substitution or elimination are going to be your first choices. Okay, so here are steps for substitution. We have to solve one of the equations for one of the variables, either x or y. So for example, if I have 2x plus y equals 10, I need to solve for y and get y by itself. So y is going to equal 10 minus 2x. So it doesn't matter which one we pick, we want to usually look for one that has a coefficient of 1, because that's going to be the easier one to solve for. Substitute that variable, so we're going to substitute all of this into the other equation. And so we're going to get a variable, we're going to get a pretty complicated equation with one variable now. And then we're going to solve that equation. Just like we did on the last problem, once we get the first value, we're going to substitute it in to get the other value and then check to make sure everything works. All right, so here's an example. We can look at this problem, and again, this is the same problem that we did a minute ago, and we did it by elimination, so we're going to do it again by substitution. And if we look at this problem, we'll notice that the second equation, the coefficient on this term is 1. So this is the one that we want to solve for. So we're going to solve, and we're going to make y equal to 5 minus 2x. Okay, now we're going to take that value that we got for y, and we're going to substitute that value into this equation wherever there's a y in that problem. So we're going to have 3x minus 2, 5 minus 2x equals 4. So notice the 3x didn't change, the minus 2 didn't change, but where the y was, I replaced it with the 5 minus 2x. And now I'm going to continue to solve this problem. I'm going to distribute the 2. So you're going to get 3x minus 10 plus 4x equals 4. Continue to solve it. So you're going to get x equals 2. And notice that's what we got earlier when we did it by the elimination method. So it doesn't matter, again, which method you choose, you're going to get the same answer. It's just depending on which method you're most comfortable with. Okay, so now once you've got x equals 2, you're going to pick one of the equations and substitute it back in, which we've already done before. And you get y equals 1. And we already checked it earlier, and we know that y equals 1 is the right answer. So when you're looking at a problem and you're trying to decide, should I use elimination method or should I use substitution method, there needs to be a little bit of a comfort level for you. So you've got to decide which way you're most comfortable. Sometimes the problems are going to tell you to do it by substitution. Sometimes they're going to say do it by elimination. But in all honesty, you can choose whichever method you're most comfortable with and solve the problem using that method. You know, there are going to be cases, if you had a problem, for example, if the problem was given to me in this form, then I would tend to go ahead and do substitution because it's already in the correct format to do substitution. If the problem was given to me in the form 3x minus 2y equals 4, and 2x plus 4y equals 3, then I would tend to do elimination because it's already in standard form and I can work it out. I can see that if I'm going to try and do substitution, I'm going to end up with fractions to deal with. So it's not really a pleasant problem to do substitution on. So when you're doing these problems, you've just got to use your judgment. I would be very, very comfortable with substitution and elimination method. Okay, so here are a couple of special cases. If we look at this problem, if I multiply, if you'll notice here, I'm going to go for the x's, and I'm going to try and get my x's to be the same. And in order to do that, I'm going to have to multiply this top equation by 2. So that means, remember, that you have to multiply the entire equation by 2. If I do that, I get 6x minus 4y equals 8. And on the bottom, I get negative 6x plus 4y equals 7. And again, add the two equations together. So 6 minus 6 is 0, and negative 4 plus 4 is 0, and 8 plus 7 is 15. So I end up with 0 on one side and 15 on the other side. So you have to ask yourself, is this a true or is this a false statement? And you'll notice that this is a false statement. 0 does not equal 15. So we're going to say that this is false. And since it's false, it is an inconsistent problem with no solution. So when they talk about the empty set, that means no solution. So then we can go through and make that decision. You can't go any further with the problem. You can't figure out what x and y are because there's no solution. Okay, so then this problem is a little bit different. And what we're going to do this time is the same thing. We're looking at our x's and we're saying we're going to cancel out our x's. So we're going to multiply the top equation by 2. And when we do that, we get 6x minus 4y equals 8. And for the second equation, we get negative 6x plus 4y equals negative 8. And you'll notice this time, again, if I add the two equations together, 6 plus negative 6 is 0, negative 4 plus 4 is 0, and 8 and negative 8 is 0, I end up with 0 equals 0, which is a true statement. So since it is true, then that means that there is an infinite number of solutions. Okay, so remember what infinite means is that I have two different lines that are basically on top of each other, and so it's the same equation written twice. So there's an infinite number of solutions. So when we want to write the solution set, we're going to write down equations for our variables. So the way that they're recommending you do it, you're always going to make y equal to y. And then you're going to take one of the equations, and I'm just going to pick the first one, and you're going to solve this equation for y. So to do that, we're going to subtract 3x from both sides. And then we're going to divide both sides by negative 2. Oops, sorry, I did this wrong. We're going to solve this equation for x, I'm sorry, because we want to know what x equals. So remember, our first spot is x. So we're going to solve this for x, so we're going to add 2y to both sides. So you get 3x equals 2y plus 4. And then we're going to divide both sides by 3. So that's how we got the 2y plus 4, because we know x equals 2y plus 4 divided by 3. All right, so let's do another one like that. So here we have two equations. Again, we're going to start it off the same way. We're going to try and get the x's the same, so we're going to multiply by 2. And when we multiply by 2, we get negative 8x plus 2y equals 4. And we get 8x minus 2y equals negative 4. So we end up with 0 equals 0. We're going to let y equal y, and then we're going to take one of the equations. We're going to go back to the original equation when we do this, and we want to solve for x. So we get negative y plus 2, and then we're going to divide by negative 4. So you get x equals negative y plus 2 divided by negative 4. Now what I did, what we can do over here is that we just basically took away the negatives and we made it y minus 2 equals 4. So we did the opposite of everything. It's the same thing. You would get credit for either way. So what this is telling us is that no matter what y value I pick, I'll get a different x value. So if I say y is equal to 3, then that means x is going to equal 1/4. So now I have the point 1/4, comma 3. Let's say y is equal to 2. Then that means x would equal 0. So 0, 2 is a solution. So no matter what I pick for y, I can figure out what x is. All right, so here's an application of some linear programming. We're going to do a couple of application problems. Read your problems carefully, figure out what you're talking about, like whether you're talking about perimeter, whether you're talking about prices of tickets, different things like that. So let's go through and do this. So we have a field has a perimeter of 320 yards. Well, perimeter, we know the formula for perimeter is 2 times length plus 2 times width equals the perimeter. And then it tells us here the length measures 40 more than its width. So the length measures 40 more than the width. So there's our second equation. So we're going to have length is L and width is W. It's asking us to find the dimensions of the field. So it's asking us to find length and width. So here are two equations. So here are two equations. 2L plus 2W equals 320. That's the perimeter formula. Length equals 40 more than the width. That's the second equation. So if I do substitution, so here's my L, I'm going to put W plus 40 in the second equation everywhere that I see the L. So I'm going to come down here and do it. 2 times W plus 40 plus 2W equals 320. So I get 2W plus 80 equals, plus 2W equals 320. So I get 4W equals 240. So I get W equals 60. Okay, so now I know what W equals. So now I can take that value and I can go back to either one of my equations. I'm going to go back to this one because it's a little bit easier. And I'm going to put the 60 in for W. And I get the length equals 100. And that's how I got my length. So what I know is that the length of the field is 100 yards and the width is 60 yards. And I can check it by putting that into the equations that I've got, and I'll figure out that that's the right answer. Okay, so let's do another one. Talking about ticket prices this time. So we have Yankee tickets and Red Sox tickets. So I let Y equal the Yankee tickets and R equal the Red Sox tickets. And it says 2 Yankee tickets and 3 Red Sox tickets are $296.66. And then the second equation says 3 Yankee tickets and 2 Red Sox tickets are $319. So our equations are 2 Yankee tickets plus 3 Red Sox tickets is $296.66. The other equation was 3 Yankees tickets and 2 Red Sox tickets is $319.39. So this time, when I'm looking at this problem, I'm probably going to want to go through and do this one by elimination because of the way it's set up. Since it's already set up in this standard form, it would be easier to go through and do elimination. So let's go through and do the elimination for this problem. And this one's a little bit different than what we've done before. If you look at this, the only way, if I'm just going to look at the y's because it's the easiest, the only way to get them to be opposite is to multiply the top equation by -3 and the bottom equation by 2. Now the reason that we multiplied the first one by -3 is because we want them to be the same sign or the same number but opposite signs. So I made the first one negative. I could have just as easily made the second one negative. So now my problems become -6y, -6y minus 9r equals -889.98. And the second equation becomes 6y plus 4r equals 638.78. And when I add these two equations together, I get -5r equals -251.20. So I get r equals 50.24. So that's telling me that the Red Sox tickets are going to cost $50.24. Now to figure out the Yankees tickets, I'm going to go back to one of my equations, 2y plus 3 times 50.24 equals 296.66. And when I solve for y, I find out that the Yankees tickets are $72.97. So what I figured out is that the Red Sox tickets cost $50.24 and the Yankees tickets cost $72.97. And then I can check that and make sure that it comes out working right. So these are two different ideas. On this problem again, when you look at the way that it's set up, I decided to get rid of the y's or the Yankees, and that's why I multiplied the top and the bottom by -3 and +2. I could have done the same thing with the Red Sox and multiplied differently to get rid of the r's. So there are different ways to think about it. And the easiest way to look at it is to take the first number here, the 2 and the 3, and basically I just multiplied each of them by each other and then changed the signs on one of them. I hope this helps. I hope you have a great week. We're coming to the end of the class. Make sure you keep up with your work and keep in touch with me if you need any help. Talk to you later.